Are you there?
Yes, I started broadcasting you live.
Okay, we're good to go then. Okay. Hello, everyone. My name is Will Smith. I'm really excited to be here. It's my first time actually in Portland, or even like coming up here in Oregon. So this is fantastic for me because it makes me, have a little mini vacation, explore stuff, and then talk about stuff that I really enjoy doing. And the stuff I'm going to be presenting to you is stuff that I do on my side, just things that I just like doing. And that's just like really it. I'm not trying to like sell anything. I'm just trying to like just show you, here's just what I'm doing, and that's should be interesting or hopefully interesting to everyone. So right now I live in San Mateo. I work at Tachyius. I've been doing F# there for about almost a year. I've been primarily on iOS. I'm moving all around on web and middle tier. And yeah, it's been pretty cool. It's been pretty cool. Been doing F# for about 1 year professionally. So before that, I've been doing a bunch of other like side projects, doing anything that I wanted that would take my interest. And so on top of that, so this is a talk about something that I'm creating or in the process of creating. It's not like finished or a production product or anything like that. It's just like, here's just something that I'm working on. So let's begin. So introduction to Ferop, and that is a whale cat. It's like the whale and then a cat face, and I really like this logo that I've taken upon this. So first thing is, thank you Portland F# for having me. Thank you Jim for having me and helping me have a place to stay. That's like a really big deal like for me because I really like not worrying about any of that kind of stuff. So it's awesome. And thank you Income Solutions for me being able to be here in the first place. Otherwise, we wouldn't have a place for me to speak. So, thank you. And I hope that's a picture of Portland. I went on Google and I'm like, Portland. I hope that is. I remember seeing it. It's actually right there. So that's kind of cool. So I think I got it right. All right. So what is Ferop? What is this thing I'm going to be talking to you about tonight? And you already have a little bit of info about it, so I'm going to get, of course, more and more in depth. So Ferop is a way where you can write inline C or C++ in your .NET application on like Windows, Linux, and OS X. I'm going to get a little bit more into like how some of this is working, but that's like the general gist of it. So it's not like C++ and that you're used to seeing in Visual Studio, or like creating like a C++ project and having it trying to link and doing the, have managed C++, have wrappers and all that kind of stuff. It's not like that. It's being able to just write C in a string and then write your C# function or an F# function that will just be able to call into it and then it'll just work. So I want to show you an example of that in here just a little bit. This will work in F#, C#, or even VB. I have like a VB example, even though I hardly ever use VB. I just wanted to see if it works, and sure enough, it does. And all of this is written in F#. So this is an example of what it looks like. So I'm going to show you all these examples are going to be in F#. So I'm sure that makes sense. So this is an example that just prints hello world, as you're just used to seeing in C. And I just have a module called native. And there's a lot of attributes here that may or may not make sense at first, but these are necessary to be able to have my library look at this and know what to do with it, know that, oh, I need to do something with this C code that I've written here. And so this is just an example of do hello world. So why even do something like this in the first place? Well, it all came down to a few years ago. I wanted to do more like game development and just .NET in general, and then I wanted to do like some like game development F#, really just like mess with stuff, not actually create a game, but just mess with different technologies. And a lot of it really required like bindings maintained by somebody somewhere in the world for that particular library that was useful and those bindings were never up to date when the library updated, and so that caused me a couple of issues. One example is OpenTK, which is actually right now it's a very fantastic library, but at that time of when I used that, it didn't work the way I would want it to on all the OSs. But there are C libraries that would work, but I couldn't really easily call into them at that time. So I needed to find a way where I can just write the C I wanted to do, and that would be it. And there's not much there, and I didn't have to worry about bindings and interop and all this other kind of crazy stuff. I just want to be able to just do my small little bit of code, and that's it. And I found myself writing C a little bit more frequently so I can interact with these useful libraries. And I know there's makefiles on Linux and OS X, and you got the Visual Studio projects, and trying to get all that work cross-platform for C for your .NET project it takes a lot of time, and I'd rather just have something just work just kind of out of the box and where you don't have to worry about that. And I realized that whenever you want to interact with C, creating any p-invoke methods, which are these. Best way to describe it, it's like a signature that represents something that is exposed from a dynamic library in OS X or Windows that you'll be able to call into, but it may or may not be right. You may have misspelled something, you may do something that would cause it to break, and you won't know it until runtime. And so that's also frustrating. And on my previous projects that I've done, like FQuake 3, where I did a lot of interop, I made tons and tons of mistakes and messed signatures up all the time, and it was very, very frustrating. I did it a lot. And so this is what sparked this project, so I can sort of get rid of this and have something at compile time check to make sure I'm doing things right. So getting started. I want to show you how to use this library, and the examples I'm going to show you are images that I have in Visual Studio that you can do today. And then I'm actually going to demo these examples, but in Xamarin Studio for OS X. So I'm going to show you one way to do it in Windows, and then I'm going to live demo a Xamarin Studio way in OS X. So this is how you get started with something like this. So in Visual Studio, create a new F# console application, or C#, but I'm going to do F# here, and call it Ferop demo, or wherever you want to call it. Just create a new console application. And then once you create it, you want to add a NuGet package under pre-release. And there you'll be able to see the Whalecat. And there you'll be able to click install. And once you install it, you'll see Ferop as part of your references. Now, this reference itself, that actual DLL, only has nothing but attributes. It has no internal crazy logic or anything. So it's very, very small. Because how this thing will actually work is when you use these attributes, an MS build task will pop up and look at these attributes and then weave and modify what was compiled that will call into the C code that you've created. It'll compile that depending on what OS you're on. If you're on Windows, it'll use Microsoft C++ compiler. If you're on Linux, it'll use GCC. If you're on OS X, it'll use CLang. It'll do this, it'll know what OS you're on and then call and compile the C code respectively to that OS.
Is that on NuGet, or do you need a special feed?
This is on NuGet. It's under pre-release.
Oh.
So I got 115 downloads, and all that's probably me. Okay. And once you have that all set up, you can then grab this quick start example from my GitHub, and the very first example is the F# one, and just copy this. And once you copy it, you'll then paste it in program FS that was created when you created a new console application. Just paste it in and just hit run. You'll do here. I'm doing start without debugging, so the window stays up. And when you do that, you'll see "Hello World" immediately from the C code that was there. And then, if you want to get creative, I can change hello world to hello Portland right in there and hit start without debugging, and it'll show hello Portland. And so it'll know that change and then compile it. It's just like you're literally writing C within your .NET code, whether it be F# or C# or VB. I prefer F#, of course.
F#
Yeah, so I shouldn't talk about C#. Okay.
Does this also work with F# scripts, F# scripting?
So it needs to be compiled to a DLL. So the MS build task will look at the compiled DLL and do it. So if I did what I showed you there in the script, it would know what to do. Okay. So score. This is good. So now I'm going to demo this, but in OS X. Let's hope I even get some of this right. Hope everybody can see that. That's good. That is excellent. All right. Sharp console application. 2. When I create a new application in Xamarin Studio, the default .NET version is 4.0, which is wrong. I need to change it to, where's that? Right here. So now here we are. You can go Add, you get Package, Show Pre-Release Packages. So it takes a little bit longer here. So there it is. I don't want Java. Okay, I think I added it anyway. I don't know why Java just popped up like in here, but that's okay. We go to GitHub, take the quick start. Paste it in. So the goal is that when I compile this, it should compile. It did. So now when I run it, it gave me a method impl exception. Let's quit it. I think Java just screwed me over. Okay, so this. Okay, hello world. And then I'm going to stop it. And then here, change it to hello Portland. Hit run. And it says hello Portland. And I just modified the C there and just hit build, and it just works. So the mechanism that drives this, it compiles the inline C to its own dynamic library based on your OS. This build task comes over and weaves the DLL that was compiled based on this that will call into what I've written there. And I'm going to go into more detail of like what is getting generated and what is actually getting compiled in C, and that's going to be the next part here. So that's first demo. So let's figure out what this thing gets generated. So this is the header file of when I hit build and the MS build task looked over it. This is what it generated. So all the stuff that you see at the top before I want to include stdio is all like boilerplate cruft that is like really, really crappy stuff that I wish actually made sense. I just went on Google and found that like I need these things. So I went with them. So I kept them there and they work. So I don't want to go into those. Those are just like mandatory things I need to do in order to expose like a C function that somebody can call from the outside. That's all. That's really what they do. And so below that is a C code that I wanted. There I included stdio that I had in the header attribute. And then there's the function that I created, native print hello world. And so that is a prototype. So here's the C, and that's all that gets generated. I just include the header file that was generated, and then this is the implementation, and there's the C code that I actually wrote in F# that and injected in. And so it compiles this as a dynamic library that I'll be able to call into. So now I'm going to do something different. I'm going to use C++ in here. So this doesn't work for just C. I just want to demo this working for C++. I include IOStream. Hopefully this will bode well. So I just created that. So I print hello world from native to. Okay, so compiled, run it, and it shows hello Portland, dream of the 90s.
Is debugging your C code?
You won't be able to debug your C code. don't write your business logic in the C.
Yeah.
Just call the functions that you just want to call. That's probably going to be hard to debug anyway. So there's that. Let me come back here. So this is what got generated on the C++ level. It's almost exactly the same as what you saw before, and here I cut out all the boilerplate that you saw because it's completely unnecessary to display all that cruft. So that's the header that gets generated, but I have extern C. That's what you have to do if you want to externalize a C++ function. So I have to do that, and so it'll take care of it. It'll know it. And then there's very similar C implement, the C file or C++ file gets generated very similar to what you saw before. And that's like the kind of the gist of this. So what are all the features that are actually involved in here? I just showed you a very, very small piece. It was just like a function that prints something. It's like, what else can this thing do? Well, it'll support all unmanaged .NET types, you know, like your standard like int or, you know, int64, byte. It won't support some things because I'm trying to figure out how to interop with it where it makes sense, like string. String, apparently, if I remember this right, by default for a pinvoke function, string will be different on OS X than on Windows of how that gets interrupted based. I think that's just kind of what they chose. I don't know why. So I'm trying to figure that out where it's always consistent. So that's why I haven't included something like that. But this will work with custom struct types. So you want to create a type and you make it a struct, and you make this struct always be unmanaged where it doesn't have any reference types on the fields. You can actually put that as a parameter for one of these C functions, and it'll pick that up and actually generate the C for that struct. And so I'm going to show you how all that works in a little bit. So this will also support delegates, and pinvoke also supports delegates, but here my library will know if the delegate is correct or not. And so it'll check for those things. And pointers and all that stuff work. And you can also create just an F# function of any type as long as their signature is valid. You can have C call F#, and the F# can do whatever it wants. And so I'm making that process a little bit like easier. So you can have C call any F# function you want as long as the signature is like, as long as the signature makes sense. So there's that. So now I want to get into how the structs work. And also be sure to pause me or stop me at any point. If you have a question on something, I'll gladly stop what I'm doing and like drop my glass of water to say something. So
Well, I was going to ask about passing parameters, but you might get it.
passing parameters.
Well, passing values between the C code and the F# code.
Yeah, that's what I'm going to be showing you right now with structs. This will also imply that passing like an int or an int64 will also like work, and just like simple like primitive types will work like that. Not every single primitive type, like string won't work right now, so I need to figure out exactly how that works across all the different OSs. But like those simple things like work. So okay, so here's structs. So how they work. Here's an example. This is how you define F# struct. Create a type, give it attribute of struct, and you have your fields. All these fields are so far just integers, and one of them, the last field, is another struct, and it also contains an integer. They don't have reference types as their fields, so therefore they're considered unmanaged types. And so therefore the in-memory structure of these are going to be the same as what it would be in C, so therefore I can generate C based on this struct and then be able to easily interop with it. So the example that you see here at the bottom, if you all can see, I don't know if anybody in the back could probably can see this or not, but I'm passing in a struct test, and I'm getting the fields or the values of the field there that I'm going to print out. And so it goes based on the same name that I've defined in here, so I can use it there. And so what gets compiled here. Now, this screenshot didn't fit in the little box. So I'd rather just show the whole thing so everybody understands rather than making it beautiful. So that's like the C code that gets generated based on that struct that I just create. If it finds an unmanaged struct that it can create, if it's a parameter, it'll generate it and know what dependencies are from other structs as well, because it generated the struct test too. So it understands how to handle these things. And so I created that and created my prototype. Not too bad. And then there's the C code that I put in my .NET code. So I want to try to demo this. It won't be exactly the same, but I'm going to demo it a little bit here. So let's go up to Hello Portland here, or above it. Sure. Is that good? Sweet. Thank you. Struct test. Now I'm going to do val x, val y. Struct. Okay, a function called print struct x. I just want to print the field x. And then copy it right here. So give me an example of why I'm actually doing this, just so you all understand what's happening. When I want to create a function that contains C code that I want to call into, I have to put the import attribute on there. So I'm telling the MS build task that I'm only looking for functions with import that have C code. So that's what's required. And this other stuff here is boilerplate that I actually have to do only in F#, because sometimes F#, when I call this function elsewhere, it'll try to inline what I've actually written there. And so when I weave this function, well, it already inlined it somewhere else. It doesn't know that, and so it'll fail. And so this will prevent it from doing that. And this is something that I have to do. I want to find a way around it, but I haven't found a very good way. So I figured this is the most natural way to do it right now at this moment. So in case anybody was wondering on that. Okay. So I have that. Build. Okay. So compiled. And my highlighting just went to cruft. Let's I hit play. And so X is this 1, 2, 3, which is what I called here. And so whatever struct I defined, I can actually almost use it as if I defined it there, and I'm just using it smoothly in C without having to worry about what this thing is actually generating. All right. Next one is pointers, arrays, and references. So all these are also supported by pinvoke itself, but I'm trying to make it where it's consistent. So what these look like, 3 functions. One takes an array, the other one takes a reference, and the other one takes a .NET native pointer. Okay. In the bottom 2, I'm actually modifying the value of R for both of those to see if I actually get that modified value back out once that function ends. And so I was going to show that you can do that, and that works. And then here I'm printing out an array, like one of the array values. Even though that's not safe, if that was null and there's nothing there, well, something bad may happen. How these get generated? So as far as like my knowledge, I think it was best to make all 3 of those be nothing but normal C or C pointers. And that's just what I went with. I don't know if that may change. I thought about making arrays be an actual like C array, but I had some issues with that. When I needed to interact with certain C libraries that need like a collection of stuff, they didn't make it like like a C array type. They always like wanted a pointer. So I think I went with the pointer just to follow that. I don't know if that's right or not. We'll have to find out and see if I get like a feedback like some future. And so there's that. So we understand that. So I'm going to try to demo at least one of these guys, make sure that they work. So going back here, let's copy this. F test. Enter by F. Let's see, 7, 9. And that's how I I really like yellow. I'm really sorry. So there made my ref test. If you can see it without the syntax craziness, let's close it and open it back up. So maybe okay. Now we're back to normal. Sweet. So create a function ref test. I'm passing a reference to int and change it to 789. So here I initialize it's a variable now because it's mutable to 0. I pass in its reference, and you know it's going to be changing to 789, and I'm going to print it out, and it should be 789. And it shows reference 789. So there's that one. Next is delegates and exported functions. Delegates are really nothing more than like sort of like anonymous functions, but you can have these things called unmanaged delegates, which are really like, well, unmanaged function pointers which use delegates in .NET. And so they're very, very similar. They're almost, if not exactly the same as like a function pointer in C. So what does this look like? Two functions. One, I just want to print something that I'm going to be doing in the delegate, which could be anything. I define my delegate. It's going to take an int, so it's just a function. Takes an int and returns an int. I have to do that boilerplate up there in order for the interrupt to successfully work. Maybe in some future, I can get rid of that attribute where you don't even need it and the thing would just work. But for right now, to get this just kind of like shipped and working, I have to do this. And if you don't put that there and you try to use it, Ferop will actually tell you that you actually need this and won't allow you. In actual pinvoke, it'll just compile and not tell you. So this prevents you from doing any bad things. Pass in a delegate, and then in the C code, it's going to pass in 1, and you're supposed to get something. And then the next portion is really just an F# function. This time I have a different attribute called export. And what export will do is it'll weave the DLL that's generated from this and create a new delegate based off of that will create an instance that lives somewhere in this module that you'll never be able to see, and C can actually call this function from the outside. So you can do whatever. You can boot up mailbox processor, do async, do all kinds of stuff, and C's just calling a function as long as that signature matches the conventions of what you've been seeing so far when calling in the C. So this is what gets generated. This is a little bit more complicated because I'm doing a lot of like different things here. So they're created a type for the test delegate that you saw, and there is the print export delegate. So like I was saying, when you put an export on that function in F#, it's going to create a type delegate based off of that will trampoline it into calling that F# function. And then it's going to create an instance of that and hold it so you can call into it without it being garbage collected. And so that's like the kind of general idea. I also down here have an extern. The extern is there. Say if I want to call this from another like C project, and all I have is a header file in the dynamic library, well, you should be able to do that, or at least a static library. And so that's why that is there. And this is what gets generated. So we understand that part. And this bottom part is where the instance gets set internally. So you know how static classes, you can actually have a static class constructor that will actually get run when you when you want to do something with that class itself, it'll actually run. And when that runs, this function at the bottom will get called with the instance of that delegate that can call into the F# exported function. I need to do that because I can only call the delegate. I can't actually call the function directly. I have to call a delegate. And so that's why that is there. So this is a little bit more in-depth. And so if you all have any questions on this, or if I'm talking too fast, be sure to totally raise a hand. Yes.
Just sort of any kind of a demo. So when you're actually generating all the actual C instructions, what are you building those into to actually execute it? I mean, are you putting files and just compiling them, or are you doing something else?
So I generate the files,
Okay.
and then depending on what OS I'm on, I'll use that respective common C compiler.
Okay.
And then I'll compile it as a dynamic library. Because you can only call into dynamic libraries from .NET can only call it dynamic libraries. And so it's like any other external language wanting to connect or do something with the C library. It has to do it through a dynamic library. So does that answer your question, what you're looking for?
Oh, no, yeah.
Okay, so that's what's happening. And the code to actually do all that stuff for all the different OSs is really not that hard once you, if you know how the actual compiler works for like Clang or GCC or like Windows, the Windows one is actually really easy compared to a GCC and Clang. But those, once you know how they work, it's really easy to actually take these C files that are generated and just run up a process to compile them. It's actually very, very simple.
So, but determine like how to actually make a C file to output, are you just trying to like figure out what headers you're going to need by guessing, or is there sort of like a subset of C you're supporting?
So there is one particular header that it does need, and that it's common in all the C compilers right now is standard ints.
Okay.
Because when that didn't exist, an int, depending on how you compile it, if you compile it 64-bit, that int will now be 64-bit. But how .NET represents an int is always 32. So standard int has like int32_t. So that's something that's absolutely required to compile any of this. So that's not like a guess. That's a thing that's actually I have to do because I need like that exact size and something that makes sense in this context. All right. So I'm going to show an example of a exported function. Oh no, there it goes. The yellow is back. All right, so let's create hello Portland and mark it as export. And then when I print my struct, I'm just like, let's just call that function. So by convention, I go by the module name, native underscore. I say export it again. I'll call it. That's by convention based on the module name or by the static class that you create for this. So now if I run this, that's what it compiles. And there goes hello Portland. And so I just created an F# function, put an export attribute on it, and just called it from C. And it just did it there immediately without having to like worry about like what do I need to do. It's like you don't need to do anything except breathe. At least that's my goal. I'm not saying it's probably that like easy, but that's what I'm hoping for. That's my intention. So there's that. Now we get into some really interesting stuff. I'm like so anxious to actually show everyone right now. What am I actually doing with Ferop on my own time other than like building it and making printf statements? So I'm doing a lot of OpenGL at home, just like learning and figuring out what in the world, how do I even learn something like this? A lot of the examples are in C, and so I like C myself. C for myself. And I don't know, I just like want to do it natively the way that everyone else is doing it, especially in the world. They write the OpenGL code, they're mainly doing like C and like C++ to do all this stuff. Mainly it's OpenGL. So I want to show you those. First one is the example that actually with the library and actually get on GitHub. So I'm going to show this, if I can find it. Okay. Run this. So here's a fractal tree. So this is in OpenGL that I'm using Ferop to call into the different OpenGL functions to create this. And the calculation of this is all doing F#. And I can also move it up and down. It's a little bit jerky here because I'm on Google Hangout showing you guys. But it's smooth on my screen. And if you don't believe me, you can totally just walk over here and yes. Yeah. I want it to be, well, it's locked in at 120 right now. I'm having some weird things with OpenGL where I'm doing bad things and frame rates are dropping like crazy when I do simple things. And so I'm like, what am I doing wrong? So there's that example. Okay. Next one is the same thing you saw, but I got a little twist here. I'm really excited to show. So there's a library, there's a C++ library called fmod that allows you to do audio. And this library is really awesome and powerful and used in like the game industry all over the place. And DSP is, I think, digital signal processing. So I'm going to analyze this audio that I'm going to play, and it's going to do something with the fractal tree. If it works. First, I got to do a get here. It's rebuilding. So here we go. Hopefully it won't be too loud. You can't see it right now, but just give it a minute. You can see it a little bit better. Say one more time. The audio is coming like the library that loaded up the file. Is coming from the C library fmod that I'm using. So I'm using Ferop to call into just those functions I need. So this is like the value that changes all this stuff that you're seeing is like a float. We can easily interrupt with a float, but I got to do a lot of preliminary work to boot up, initialize the fmod system and do a bunch of other stuff just so I can get this float value. And so I'm able to do that very easily with just like 2 functions. And I didn't have to like create all these different projects and make files or anything. I can do it all like right there. And so I'm just showing off that. Okay. So there's a bug here. Even though I quit, oh, I guess I did quit this time. Okay, cool. Usually I just hang there and I have to go force quit and do all this because I haven't like allowed you to quit anything. So the next one is Foom. So this is something that I'm toying with right now. My intention is to hopefully one day, once I'm smart enough, actually render a like Doom level. So far, I got a couple lines on the screen. So you're going to see lots of lines on the screen. Run it. You can see here if I'm going to zoom in. This is a level from like a custom Doom level made by somebody, and I'm right here. I'm just loading in like the outline of the level. So all these are like polygons, and since all the polygons and how they're arranged, I'm drawing lines for each of them, and so that's the result that you'll get from there. So it's not just like an unordered set of lines just splashing the screen. Anyone can do that. It's like these are actual polygons I'm now going to render. And so hopefully in the future what I could do is, since I have the polygons, I can triangulate them. And once I have the triangles, then I can do anything that I want. I can actually put a texture on it. I can do whatever. And so I'm not there yet because I'm still learning like how to do math. I can't add like 1 + 1 right now. So I'm kind of like stuck. But that's just something that I'm like trying to do because I'm really passionate about like games, and I like doing like internals and like figuring out what in the world's like going on. Like you have all these game engines like Unity and Unreal. It's like I can create a game. It's like yes, you can. You can go ahead. Like But I want to know what's actually going on at like its level. Like, what are they doing? Like, that's where all the really, really smart people are like there doing that kind of stuff. And I just want to learn at least just a piece of like what in the world they're doing, because that, I don't know, that interests me, because you have a lot of control and you can do really cool things once you know that. And so for F#'s case, I can do really cool things.
Is that your code drawing polygons in C, or what are we
saying? So this is calling OpenGL, which is always C, no matter what. But as far as like, so how this works, when I get a level, there's an unordered set of lines, each with like a start and end vertex, and I have to manually go through and like connect them and see if they're connected correctly, and see if they actually form a polygon when it ends all the way, see if it traces. And I'm doing that in F#, and it's actually very, very fast. I can load like a level and like load all this stuff up very, very quickly, and I can parallelize it if I want to. It's actually very, like, since I made everything very, very functional and didn't like have references to anything, I'm just like, I'm using like an immutable hash set, which is from .NET's BCL on NuGet. So I'm using like that kind of stuff, and there I can take advantage of. Like having these like small little pieces separated out and then parallelizing things that I need to make it go a little bit faster. Not a whole lot faster, but just a little bit. If that answers your question? Okay. So I can kind of move around a little bit. That's about it. Okay.
And that was just like going out, finding some C code, dropping it in, or you're working 50% at C, 50% at F#.
No, this is, so the only C that I'm doing here is just calling in the OpenGL.
Okay.
Everything else there is F#. Like I have all the types defined to draw all of these things. Once I have the data, I just pass the data to OpenGL, and then it just goes, I love your data, I want to draw it.
Right.
And that's about as far as it goes. I'm trying to figure out ways to abstract things I'm doing in OpenGL to make it a little bit more sensible and a little bit more composable, because OpenGL is not composable and it's a big mess. It's like it's actually very, very difficult to work with because of just the nature of it. It's just like, what is this thing doing? Because you can get it wrong and it won't crash, and it may still work, but the minute you go to a different OS, it doesn't work because you actually did it wrong. So now you got to figure out and do it right, and now that OS works, and now this one still works too, but you wouldn't know that unless you tried it somewhere else. So it's extremely like, how does anyone do anything? No wonder nobody like does a lot of this stuff because of that kind of thing. But I just find fascination in it because, I don't know, I want to be able to have control and do things, and if I want to do things like using F# and I want to make things like fast and performant, I need to know these things in order to do it. And so, my last demo, this is something that may be a dojo. It's something me and Matthias are actually working on. And so I'm going to show you this. So this actually pushed me to the limit. I'm actually like learning a little bit of like a little bit more math, and I had some help from a friend, Paul, where I work on doing some of this. So I'm going to show this. Okay. So this is an FSX script I'm going to run. It's a black screen, which is totally okay and what I'm intending. So now I'm going to spawn a sphere. Spawn a sphere. Now I'm going to change the scale of it and the color. I totally forgot about the color. And then I want to spawn another sphere and have this thing rotate around it. So I can also do crazy things like spawn 100 of these guys, and hopefully the thing doesn't crash. I don't know. Let's see what happens. I have actually no idea what will happen. I don't know. But let's find out. Let's experiment on the fly here. All right. I. I don't know how this will function. Let's find out. Does not match flow theory 2. No. Okay. There we go. Got a bunch of balls all over the place, and that's kind of freaky to me. So we do all kinds of interesting things. I can try to go on the, instead of the y-axis, I can go on the x-axis. Of course, where did they go? They stopped in the corner. Let's change that to z. There we go. So this is hopefully going to be a dojo where we'll be able to have planets and be able to actually use gravity on these things, and you'll be able to actually write your gravity equation, which I don't even know. I know Matthias knows because he knows math better than I do. So that's something that's hopefully in like near future, like really, really soon. So far we got the hard part, which was actually drawing a triangle, which took us like 5 hours to do. And once we got the triangle, then we were able to like figure the rest of it out. But it took a little bit of time.
What was the hardest part?
The hardest part? The triangle.
I mean, like, of that process, 5-hour process.
So, again, OpenGL is very flaky. So you're like, oh, we got to call this before this. But it didn't crash, and no memory exploded, and it still accepted it. What in the world's going on? And then when we switched the orders, somehow like stuff started working. We're like, okay, don't change it. Just leave it there, and then hopefully it'll like continue working. We won't have to bother with it. It's a little bit painful, but this is like raw. This isn't like a framework or anything that I'm doing here, other than like using my library and then calling OpenGL directly as is you would in any OS or platform. So this is like starting from like the ground up and building it, including like the shadow that you're seeing there, because otherwise this would just be a flat, color, and it wouldn't even look like a sphere. But adding like figuring out what the shader does that can give you that shadowy effect, like when it's getting near like the back. That took a little bit of time to figure out. I mean, there's a tutorial online that tells me how to do it, and I learned a ton from there. I actually learned what the dot product does. Finally, it took me forever. Which is a really simple thing, but for me, it's like really hard to visualize these things. So the best way for me actually learning any of that stuff is actually see it like this. Because here now I can actually manipulate and do all kinds of crazy things right in the F# interactive in the script file. I can just do whatever just to experiment without having to worry about like, oh, now I got to go recompile. Did this work? Oh no, here I can just do it immediately.
Yeah, that's it.
Can you see the actual recursion?
What is it?
On the Mac screen?
Oh, the frames. Right now it's 150. This is like really weird sometimes. Like sometimes this will be like 1,000 to 2,000, then go to like 50, then go to like 2,000, then go to 50, and I'm probably doing something wrong. But this should be breaking right now. I don't know why it's working. It's mostly where I'm having problems with the garbage collector. But I think I'm figuring out how to avoid it. So one time I decided to spawn, well, what happens when I spawn 100,000 spheres? Okay, that did, not even like displaying anything on the screen. It still just brought it to a crawl because I'm copying each object. Because here I'm just copying the state of what was passed through and giving a new state. Well, that's allocating stuff on, the heap, and so we got to collect that and do all that kind of stuff. But it's only until you get like 10,000 it's actually okay. Even the mono garbage collector can actually handle this. And definitely the CLR garbage collector can handle it. It's like very powerful, especially when you turn on like the server garbage collector, then it actually like really starts shining really, really well. But I'm also like thinking of ideas like in game development, how far can you go functionally before it actually starts to become a problem where you have to start breaking rules? I'm just trying to figure out what is the best balance between that. And so I had one example. I've like changed this about 50 times like in the last week. So to state that it's in right now, I did yesterday. So before that, I was actually just mutating the values so I can spawn more and more without like hindering the garbage collector. And that seemed like worked pretty well. But then I tried it again where I have, I just want to bring up a new state, and it was actually fine. I think it just had like a wrong environment that I was setting up, and it seemed to actually be okay when you're just like below 10,000 like different things. It seemed to be like okay. But I'm still like exploring this, and I'm trying to find that out. It's actually kind of challenging, and it is a problem when you use something like using like mono for like iOS. It can be like very challenging. Or like Xamarin iOS. It can be very, very challenging with the garbage collector. It's like, what do you do? It's like, what happens? And it's like, oh no, well, it's like frame rate is like 5 and we can't ship this. It's like, what do you do? I'm like thinking like in their minds, like, well, like how would you go about attacking this problem? I find it very fascinating. I find it very fascinating for performance issues, and I love diving into it. That is it. So now I don't think I can quit out of this. Okay, maybe I can. Okay, there we go. Hit reset. So nothing is perfect. I have lots of issues with this thing that I still have yet to resolve. The string type for Ferop is not in there yet, and I don't know if I'll be able to get it in or if it makes sense, but I know the utility of it is extremely useful, so I'm going to pass an array of characters, but the string type in .NET's a little different. You can get the characters out of it, but it's not natural to get the characters out of it just to pass a string. So, yeah, you can technically. You can like say, all right, pin this string, get like the raw pointer, like we're getting like S byte, and then pass it in, and that works too. But I want it where you can just like call it and not like worry about it, and something that makes sense. But it's different on each OS, and I got to figure out what's going on. At least that's that. I may be wrong on that. There's some bugs. Creating two like exploitive functions with the same name in different modules causes naming conflicts. That's a simple bug that is like I can like, probably easily resolve. But I'm aware of it, so these are just things that are like not perfect. MS build is like really weird. Sometimes they'll just like, I'm not going to do anything for you. And nothing, like my changes don't like reflect what I wanted. But Xbuild seems to be doing just fine on mono, but MS Build itself in Visual Studio decides to like not work sometimes. So I'm probably doing some things I shouldn't, so I need to look into that a little bit more. And this stuff isn't like production ready. I wouldn't recommend using this in production. No. Don't use it. Use it for prototyping. It's like, hey, what if we use this library and call into it? Like, how, like, will it actually give us a benefit or not? It's like, well, this would be good because you can easily do that. And the things I didn't get into in here is like, how do you use like external libraries in this thing? Well, that all depends if you actually know the type of C compiler. So I have different attributes for the different types of OS with this associated C compiler, and I give you access to all like the command line arguments, so you can like include like header files, or you can static link libraries, or like whatever. You can do all that, but that's like an advanced section that's really just C related and nothing like who wants to hear about here's how we include a dynamic library in this argument. It's like that is boring. It's like I don't want to do that. Just go look it up. And I don't have very good integration with existing C or C++ projects. So if you have a really big C or C++ project, I don't know how well this can like mold onto it. I know I have the header file that has like you can like include it, and then you can probably include the dynamic library, and it'll probably work. But I don't have a really good story for that. So that's the thing that's not there. But that's why I'm trying to build a really big project to give me a sense of what I should be doing. So I'm building this library really like for myself. because I need it. I feel like I need it, but I want to try to make it where it's accessible to everyone because I can get feedback so I can help me build what I want to build. So that's where it's at. Thank you.
Thank you.
Remember the well cat.
So a very non-meaningful question. What does Ferop mean?
It means absolute garbage. Exactly like this name right here, TIHAM, which is my nickname for like the past like 15 years, means basically nothing. Well, Ferop could be F sharp interop, kind of like combined together, like.
Far East Russian Orchestra.
Oh boy, what are you really presenting to us? Is there like a hidden message here?
Cool. Thanks, Matthias, for helping us get this broadcasted.
Matthias, are you there? Matthias? Bonjour! Okay, it didn't work.
All right, I think we'll go ahead and just close down the link then.
Okay.